Okay, so previously we looked at when we were taking readings from the world and we were able to interpret them as analog values. And so, like, if you had an input, let me get something a little bigger here to work with. So you're reading voltages, and you're able to map these voltages to a value between 0 and 1023. In the case of the Arduino, that's the resolution we have. Whereas before, with the digital inputs, we could only read it as 0 or high, basically. Okay? For that, that same signal. So up here it was high, up here it was low, and somewhere here in the between, we weren't sure what it was going to be. Whereas in this case, we can get intermediate values, which is useful to kind of get like a range of things, right? Because the world in reality is analog, not digital. But digital devices can only interact with the world digitally, and we have kind of these hacks here, like an analog to digital converter, to allow us to get some more granularity. So another way that we can use analog is it'd be really nice to be able to output something as an analog value. And so some devices have something called a digital to analog converter, where they could try to recreate this kind of signal using an output with some kind of stepped resolution. It might look something like this. Okay? Now with the Arduino we can't do that, but we can kind of cheat a little bit, and we can do some things that might approximate that. So for example, one way you could think of it is dimming a light bulb. If you wanted to do like a medium voltage, you could have the light be medium, like halfway on, halfway off, right? You might have dimmer switches in your house, which depending on how they function, would either like give like a partial voltage or have something like I'm about to show you here that operates instead. And so in the case of the Arduino, instead of being able to do all this, we have to use something called AnalogWrite, because the Arduino can only be on or off, right? It can go between 0 and 1. And so what we do is we can turn something on for a long time and then it's on all the way, or we can turn something on like for a little bit and then turn it back on and turn it off. And so like if you had a light connected, it'd be blinking on and off really fast. And so you could do this a certain number of times a second. And then, or like you could think of like this kind of here would be on for a certain amount, off for a certain amount for each cycle, okay? And the rate, the amount that they're on and off, and there's different ways that we approach this, but essentially we have this thing called like a duty cycle, which basically you have some kind of cycle period that has a certain amount of time, and then during that interval you're going to switch on a certain amount and then off a certain amount, and the higher, the more like on you want it on, the more you want it turned on for, like the brighter you want it to be, the higher that analog value you want, then the longer it's going to be turned on during that interval. And so I actually found a diagram here that's kind of helpful, and this is from the Arduino website. I was talking about PWM, which is called pulse width modulation, which is how we do the analog write. And you can see here where it's turned off, this would be 0% duty cycle, and so it is an 8-bit PWM, so which means we have a maximum value of 255. And so you can see if we're writing at a quarter of that value, 64, we're on a quarter of the time and off the rest of the time. If we're doing analog write 127, we're on for half, off for half. At 75%, we're on 3/4, off for a quarter, and then 100% we are always on. Okay, and so this would be full brightness, this would be like 75%, 50%, 25%, and this would be off. And so we have that kind of range here, and so you're able to control that. And so for things that where this would work for it, you can have kind of this analog control. Now it's not obviously true analog control, because that would mean that you could do an intermediate voltage, but this is kind of like a hack that we can use to go in between, and we can use this for a lot of things beyond just controlling the brightness of an LED. For example, you can control the speed of a motor this way, and you can do some other things too. So anyway, this is what the AnalogWrite does, and so I'll show you how to implement it. One other thing before we get into the implementation, so this is a kind of special functionality that not all the pins on the Arduino are capable of doing. Just like we only have a specific number of pins that can do an analog read, we're limited to the number of the pins that can do analog write. So we have a pin 3, a pin 5, a pin 6, 9, 10, and 11. These are the pins that can do that analog output, create that PWM signal. You have that little note right here about the squiggly. And so those are pins that are capable of doing that. And you might be able to actually build the code for that like separately to control other pins, but these are the ones where it's kind of built into the hardware. Okay, and so anyway, now we'll go ahead and take a look at implementing it. So let's say, let me pull up a different sketch. Okay, so we've created a variable to store the pin that we're going to use here. We're going to use pin 10 as our analog write pin, and we'll say, we'll set the pin mode here. Analog write pin, and we'll set that as an output. And then what we'll do is we'll just say in our loop, we'll say analog write, and the way we use this is we send both the pin that we want to use, analog write pin, and then we tell it the value you want to write it to. So whether it's 0 or 50 or 100. Remember, the maximum value would be 255. Okay, so we'll go ahead and give this a test in the simulator. So the compiler for the simulation isn't working right now for some reason. So in that case, I'm just going to have to show you here, and so you won't be able to see it. But basically, you can change this value, as I said, anywhere 0 to 255. You can also, you could have some kind of input and do like an analog read maybe from another device. Maybe you have a potentiometer connected, and you can, based on that input, you could say if the input is greater than a certain amount, we'll have it to here. Sorry, no semicolon there. Well, so if it's above 500, we'll do this. If it is, instead, we'll say else if it's above, say, 300, we'll do something else, or we'll have an else case for something else. And so we'll go 255, we'll go to maybe like 100, and then like 25. And so you can switch brightnesses. And there's actually a way that we can directly map the input from here onto there, but we'll get into that later. Okay, so go ahead and test out this analog write, try it out, have some fun with it. Okay, and let me know if you have any questions.